Imagine you're checking if your buddy's home. That's what ping does. Just a simple yes or no. Now Traceroute is asking for detailed directions to your friend's house, with a stop at every coffee shop on the way. It maps out each leg of the trip and tells you how long it takes to get between them. Here's the scoop. Traceroute tweaks something called TTL, or time to live, in IP packets. Each router along the way reduces this TTL by 1. When the TTL hits 0, the packet gets tossed out, but not before the router sends back an ICMP time exceeded message, telling you where it bailed. Traceroute starts with a TTL of 1, then 2, and so on, gradually revealing the entire route to your destination, one step at a time. Think of Traceroute like sending out little exploratory messages with a built-in self-destruct timer. You kick off by sending 3 probes, each with a time to live, or TTL, set to 1. The first router intercepts these and drops the TTL down to 0, then sends back an ICMP time exceeded message. Congrats, you've just identified hop 1's IP address. Next up, you increase the TTL to 2 and fire off another batch of probes. The second router plays its part, sending back a response and revealing itself as hop 2. This process of discovery continues hop by hop until the probes reach their final destination. When they do, the destination responds with either an ICMP port unreachable message if you're using a UDP traceroute, or an echo reply if you're using ICMP traceroute. Here's a fun twist. Windows sends ICMP echo requests when you're running Traceroute. Meanwhile, Linux and Cisco have a preference for sending UDP probes to a high port number by default. It's like each system has its own preferred way of sending mail through the network. Looking at a traceroute output, each line gives you the hop number, the router's IP address, and 3 round-trip time measurements. Spotting an asterisk means the probe took too long and timed out. Basically, that hop decided not to RSVP to your party. But if you see 3 asterisks all lined up, that hop's not just late, it's completely ignoring you like an ex at a reunion. This often points to a firewall blocking ICMP time exceeded messages. Now, if a certain hop shows a high round-trip time, there's likely a delay happening at or beyond that spot. But here's the twist. If every hop afterward also has high latency, the traffic jam is probably right at that first slow hop. On the other hand, if one hop is dragging its feet and the destination is speedy, that router is just too busy with other priorities to bother with ICMP traffic. Let's dive into some common traceroute traps that might catch you off guard. First up, if you're running Traceroute on Windows, it uses ICMP echo requests. But switch to Linux or a Cisco router, and it defaults to using UDP aimed at a high destination port. Next, those pesky asterisks in the output might not mean the path is broken. Sometimes they're just indicating that a firewall is blocking ICMP time exceeded messages, but your data could still be moving along smoothly. As for asymmetric routing, think of it like taking a different route to and from work. Traceroute only maps the path to the destination, leaving the return journey a mystery. Lastly, by default, Cisco iOS Traceroute uses UDP probes. If you want to use ICMP instead, you'll need to go with the Traceroute IP command. That's Traceroute summed up. Manipulating TTL, uncovering each hop along the way, and interpreting what you see. And remember, there are those funny quirks between Windows and Linux. Check out Courseiva.com for some CCNA practice questions. You're on the right track.